Seagulls in their element. As drawn by an invisible hand, the gulls circle where schools of fish have been driven to the surface. They guide the way to the whales across the endless plains of the sea. Marine biologist Antonella Servidio investigates the whales of the Canary Islands for the European Union. 28 species of whales and dolphins live in this region. No map exists to predict where they will be. The biologist's trick is to follow the birds to where the whales drive the fish to the surface. Pilot whales. It is likely that this school has existed here for thousands of years, transmitting their knowledge through generations. Antonella is concerned that the increasing ocean noise interferes with the communication of the acoustic-sensitive animals. But how to judge what cannot be perceived? To get a better idea, the marine biologist dives with them. Her camera documents contact between individuals, though details of their communication remain a secret. Will they accept her? The supremely graceful beings appear like ghosts out of the past. Much of their life is spent at depths of up to 1,000 meters. Of their mysterious world, we know only what they're willing to share with us. Pilot whales are highly social and live in pods of up to 100 individuals. Resting now, they're some of the fastest divers, which shows in their muscular bodies. Antonella is fascinated by their sinuous movements, set to an unheard aquatic rhythm. What are they saying to one another, and how? Their clicks and whistles sound strange to us. Though they are a language for them. It's easy to assume that their language is so different from ours that we fail to see similarities. How would they communicate in a noisy environment? How do they behave when they dive out of sight? Do they dive as couples? In favored formations? Nobody knows. For Antonella, this is overwhelming. A couple caressing each other. To defend their groups, males are a third larger than females. Still, the females are the leaders. Biologists shouldn't speculate about animals' feelings, but some are more playful than others. A sheet of plastic becomes their game. What are they thinking with their brains bigger than ours? Is this the whale's invitation to play along? A confident bull checks out Antonella, a curious female close behind. Using their sonar clicks, they can see inside bodies. Like all toothed whales, they produce extremely powerful clicks within their foreheads. With echolocation, they see a complex map of their three-dimensional underwater world with X-ray precision. And they stay in contact over long distances. Nothing to be worried about. No noise from ship propellers. Hard to believe in this quiet surrounding that the global ocean noise doubles every decade.
Pero en plan protección, voy a salvar a mi cría o...
Sí, sí, sí. Well, actually, I don't know if you realize, but we swam into the shit.
Ah, no, I haven't seen it. I was...
Probably there's some small pieces.
No, I haven't seen it. I was always like...
Yeah.
Back on patrol, Antonella and her colleague Maria pay attention to areas above submerged mountains and escarpments, rich in life and fish, recording the daily changes of the sea. Dolphins. A few years ago, the fishermen could not tell a dolphin from a fish. Today, they even radio Antonella the positions of their encounters. Antonella also uses acoustics to trace their behavior. As soon as her underwater microphone enters their sphere, the playful dolphins come to check it out. Every click is recorded. The dolphins are thrilled. A new toy. Clicking joyfully, they dance around Antonella's boat. What's that noise? Can't come from the fishing boat.
Maria, I hear something.
A shrill sound, so loud that the recording is peaking. Where are the dolphins? It's important to document this. Behind the cliff, a Navy ship. Antonella is on highest alert. It sounds like anti-submarine warfare training. Position, time, all recorded.
For 11 minutes, we have been hearing signals. 4 minutes ago, behind the cliff, a ship appeared.
Shortly after midnight on September 24, 2002, NATO began their hunt for submarines. At 7 a.m. the next morning, the first dolphins wash ashore. To prevent the disoriented animal from drowning, the locals immediately take him to a relief center. This does not happen often here. A healthy-looking animal without any obvious wound. Worse is the fate of this beaked whale. For him, help arrives too late. What is the cause of death? 6 meters long, Antonella starts to secure the evidence. More bodies float ashore. NATO conducted an anti-submarine warfare exercise. 58 ships generated extremely loud sonar waves to locate positions of 6 submarines. The fishermen are helpless. More and more whales wash ashore. On the sharp rocks, every panicked movement cuts deeper wounds. The whale struggles for life. His blood begins to stain the water. They try to pull him out to sea, but his fate is sealed. We will never know what memories flicker in his dimming consciousness. A few hours later, he dies. Is there a connection to the Navy exercises? The evidence is strong. A Spanish admiral arrives to meet the locals.
The pity is that we come here so seldom, because these islands are the most fortunate in the entire world.
You do not have the right to cause so many animals to die for the sake of your exercises.
Among the millions of animals, there are always a few sick ones. They probably died before we arrived. I beg your pardon.
You are destroying our livelihood.
A similar response is given by leaders of other NATO countries. At a 2005 press conference on board an aircraft carrier, the British Rear Admiral Charles Stiles explains,
there are animals and fish. We take every measure we can. I cannot imagine a time when we would not have to make use of that sort of technology in hunting for submarines.
Could the Navy be right? Is a disease to blame? More images from 2002. Whales continue to strand. Veterinarians of the University of Las Palmas start the autopsy. They have to work quickly before decay sets in. It didn't starve. The stomach is still full. Then, gas bubbles in the liver. In blood and organs, gas bubbles are fatal. Samples are collected for further investigation. What caused these bubbles? Is it premature to blame the Navy? Did they die during a dive? Hardly anything is known about the whales' deep-sea lives. On the island of El Hierro, Antonella's colleagues are trying to learn more.
It seems 3 adults.
3 adults. There are no cats. Good for tagging.
Both from the land and the sea, the team observes the positioning of the whales.
Maybe you can answer me like if you were from land.
It seemed 3 animals without caps, so good for tagging.
Because whales dive deeper than most submarines, their deep-sea habits remain a mystery. A high-tech sensor will be attached to a whale and for the first time will record its underwater movements. As small as a lunchbox, as expensive as a car, the microspy has enough memory space to record for 24 hours and can withstand pressures of up to 2,000 meters depth.
Head that way, turning a little.
The whale will not be injured. Tagged. From now on, the tag will record every sound, every movement. Meanwhile, Antonella travels to the island of Lanzarote to meet other scientists. Alexandros Francis is from Greece. He's the first scientist to investigate the impact of Navy exercises on whales. After a Navy exercise, he was unable to find the local beaked whale population, which he'd been observing for years. Images from 1996. NATO ships are testing new sonar systems in the Gulf of Kaparsiakos, off the Greek coast. Military sonar techniques mimic the way whales have been hunting prey for millions of years. Both use sound waves to track their fleeing prey. The echo reveals its position. Whales are extremely sensitive to sound. What happens when they hear the military sonar, which blasts through the oceans louder than a jet plane? Alexandros is certain that the noise can be fatal. He witnessed the first whales washing ashore just a few hours after the NATO exercise. More and more whales stranded. Alexandros recognized them. It was the group he had followed and grown fond of over the years. Could it be a coincidence? So many whales stranding on a single day? Each within 12 kilometers of each other? A whale strands in the Gulf of Caparisiacos every few months. But 16 in one day. Could it be that the sonar from one military ship struck the whale populations of the entire bay? When exactly did the exercise begin? The military gave no answers. Alexandros started his own investigations. Though the University of Athens and the Navy asked him to keep quiet, he made his observations public. Immediately, the university cut all ties to him. It can't do without Navy funding. Alexandros and Antonella have been searching for beaked whales for hours. Nothing.
Pero están con los listados?
Even the trained eyes of the biologists can't spot any animals. Maybe the whales are just hunting in the deep. Change of course. They visit the beaches where beaked whales have been stranding frequently in recent years. Also on board, Vidal Martin, director of the Whale Museum of Lanzarote. He has mapped the reported strandings on the Canary Islands and linked them to naval exercises.
Was there more than one species involved? Yes, many species.
Naval Exercise 1985, Fuerteventura, 12 stranded whales at 4 locations. Naval Exercise 1986, Lanzarote, 5 dead animals. 1987, Lanzarote, 5 bodies. 1988, 6 strandings. 1989, 20 dead animals. 2002, 16 strandings after a naval exercise. Water conducts sound 5 times faster than air. But are the sonar sounds really strong enough to fatally affect entire whale families swimming 50 kilometers apart? This question can only be answered by the Navy itself, but they keep a tight lid on their secrets. A British sonar expert nevertheless agrees to meet Antonella. She leaves for Glasgow. Scotland has one of the most secure submarine bases in Europe. She arrives early to take some images of the base before the meeting. The Faslane Royal Navy Submarine Base, 30 miles from Glasgow, is the headquarters of the Strategic Submarine Fleet. Can today's underwater sound technology be powerful enough to beach whales within a radius of 50 kilometers? Ed Harland worked in the defense industry for 38 years. During the last 12 years, he's headed sonar drills and examined the possible impact on whales. Antonella's request to visit the submarine base has been refused for reason of national interests, security problems. Outside NATO forces, there exist no more than 300 potentially dangerous submarines. Does their threat justify all this effort? Ed Harland has just retired. Now the base is closed to him as well. Memories flash up. Sonar technology was developed fervently in Britain during World War II in response to German submarine warfare. it became practically impossible for British convoys to pass the naval blockade. The German submarine fleet almost succeeded in cutting the British supply lines. Submarine hunting became the most important task of the Royal Navy. In return, the Germans kept improving their submarine technology. Bigger, quieter, more dangerous. The British sonars remained limited in range, which did not exceed 2 miles. They still lacked the necessary know-how to detect submarines at a distance. Then, the Cold War. Soviet nuclear submarines armed with intercontinental missiles pose a new threat. Sonar technology regains prevalence. Early 1960s, the U.S. Navy has a breakthrough. The new sonar models use lower frequencies. Their sonar range increases up to 100 miles. At that time, nobody considered a possible threat on ocean life. Russian submarines patrol from the North to the South Pole, ready to deploy their fatal weapons. Currently, the quietest submarines are built in Germany. Fuel cell driven. Stealth technology. A new challenge for sonars. The arms race continues. But what does this mean for the whales? Antonella is keen to learn what Ed Harland has to say.
Good morning, Antonella.
And here we are.
First Lane Naval Base, where we have submarines and surface ships in, but this is not the best place to view the base. If we move down the hill, we will get a much better view. Okay?
Ed agreed to provide Antonella with some necessary insight into the sonar technology. From this base, Ed started a few sonar expeditions. His job, among others, was to optimize the positioning algorithms for the sonar hunt.
This is Fast Lane Naval Base, a submarine alongside.
Okay.
If you'd like to take a closer look.
Thanks.
He shows her the Vanguard-class nuclear submarines. They look harmless, but are armed with nuclear warheads.
Okay, that's one of our current submarines. If you'd like to come and look at the computer, I can tell you more.
Okay.
Okay?
Does the Navy really do all it can to preserve the whales? Ed has brought along some simulations to show what happens during a submarine hunt.
Okay, Antonella.
The danger lurks everywhere. One torpedo can sink an aircraft carrier. 7 torpedoes, an entire fleet. Enemy submarines could be hiding anywhere. Modern frigates use hull-mounted sonar systems, the most powerful sound system ever developed to spot submarines over long distances. This technological masterpiece consists of hundreds of crystal staves which expand in response to an electric current, generating a tremendous pressure and emitting sound waves with a frequency of 35 to 3800 hertz. If a submarine is hit, it emits a distinct echo, revealing its position. The ocean is a complex acoustic environment. Different thermal layers reflect the sound waves between the warmer surface layers and the colder deep ocean waters, like in a fiber cable, channeling the sound waves across large distances. Submarines often hide below these layers. This is why a second gigantic speaker system is lowered, sending low frequencies into the bottom layers, increasing the range even further. This system is used by all modern navies throughout the world.
That incidentally also has active sonar, and together they should be able to get complete coverage of the water column for a submarine. So that is typical of a modern ship.
These numbers and facts disclose to Antonella the enormous range of the sonar sound waves. The Navy and military claim to put all their cards on the table. In truth, this important information has been held back from biologists so far. But why? If whales are dying from these sonars during times of peace, what will happen during times of war? Ed affirms that up to now in England, no whales have stranded after sonar exercises. But no wonder that deep-diving whales never stranded on the British coast. They live 100 miles offshore, where the shallow shelf drops off into the deep waters. If they are fatally struck by sonar, they will drift away with the Gulf Stream. At the University of Aberdeen, zoologist Colin MacLeod collects stranding data from all over the world. Often, neither the size, nor the sex, nor the circumstances of death are known. By studying recorded whale strandings, he indirectly collects data on their territories. But Colin is not interested in military activity. Antonella has to investigate this herself. She hopes to find evidence in Colin's data that would either prove or disprove the connection between the powerful sonar technology and the strandings. Colin has registered a total of 16,000 strandings. The far-reaching mid-frequency sonar has only been deployed since the early 60s. Have any abnormalities been recorded? Any sudden increase in strandings?
In this case, it's stranded in London, which is about 52.5 degrees north, 0 degrees west. Put in the ocean it's in, it's North Atlantic. And also identify areas where we know very little about beaked whales. For example, if we look down the west coast of Africa, though we've got no records in our database, it's probably not because beaked whales don't occur in this area, but more that there's very little research.
1805, the first whale strandings are recorded. Colin's data in fast forward. There have always been less than 20 a year. Many years, the numbers stay constant. Shortly after World War I, the numbers rise. Even more during World War II. 1960, a sudden jump globally. The modern sonar is invented. Or is it just pure coincidence? Antonella's next meeting is in London. Colin's data provides information on areas of conflict. Might there be more evidence within the data linking the use of sonar to whale strandings? In 1960, the numbers rose dramatically. On the other hand, the public interest increased at the same time. Could that explain the rise in reports? She takes a closer look at Colin's data. Japan, 1960. Yokosuka, the most important American Navy base outside the U.S. Mass stranding started right after the new sonars were put to use. The same is true for California. Strandings began in the 60s, near the naval base in San Diego. Coincidence? In the pathology department of the Institute of Zoology in London, veterinarian Paul Jepson dissects a stranded cadaver, as he does almost every day. What was the cause of death? He looks for parasites and external injuries. Everything is documented. To investigate the internal organs, he opens the body. Skin and tissue samples are taken to the lab to look for heavy metals and contaminants.
Hi, Anta. Come in. How are you?
Fine. It's like just stranded.
Yeah, this is a juvenile female common dolphin. One of the largest organs in the abdomen is the liver, and it looks fairly normal in size, shape, colour and consistency, which are the things we look for.
In the last few years, Paul has found unusual damage to the organs, which until then had not been observed.
Let's start with the normal. So this is just a picture of a normal common dolphin liver, just like what we've seen today.
Okay.
And all these cavities are just filled with gas. And not only in the liver, but this is in the kidney. And what might be happening with gas embolism is that maybe there's something that scares these animals or panics them or makes them to really dramatically change their behaviour. And what might happen is that they shoot to the surface perhaps very, very fast.
According to today's knowledge, deep-diving whales must surface slowly. If a whale is startled, he's presumed to speed to the surface. By shooting up too fast, the environmental pressure decreases. Micro-gas bubbles, naturally dissolved by surrounding pressure, expand rapidly. Air bubbles start to block the blood flow to vital organs. Cavities balloon in the liver, some to the size of tennis balls. The blood flow stops. Oxygen is cut off from the heart and brain. Disoriented, the whale surrenders itself to the currents.
You get a very rapid decompression or rate of decompression, and of course that's a major trigger for gas bubble formation.
At first, colleagues mocked Paul's theory, doubting that whales could get the diving disease. Meanwhile, they widely accept that it is dilating gas bubbles that destroy the healthy tissue. Antonella returns to the Canary Islands. The weak point in Paul's theory, it is difficult to prove. Very little is known about the life in the deep oceans. Is it like mountainscapes with drifting currents of ocean clouds? How do whales hunt in deep ocean canyons where it is pitch dark? Loaded with questions, Antonella returns to Gomera, her home of the last 7 years. Antonella grew up in Italy, inland, but since she can remember, she has always longed to be by the sea. As a young scientist, she came to the Canary Islands to study whales and other mysterious marine animals. The archaic but endangered sea turtles have become one of her favorites. Monuments of time, their slow and steady lives emulate the eternity of the oceans. Part of Antonella's work for the European Union is the protection of breeding grounds. Luckily, sea turtles don't seem to suffer from the extreme sonar noises. Still, they had their share of struggles. Yet Antonella has hope. Living far from her family, Antonella is still happy to live where her work is needed. The Canary Islands are a chain of volcanic peaks that have risen from the depths of the Atlantic Ocean. Whales have been living among these islands for millions of years, whereas humans first arrived 2,000 years ago. Back in her office, the evidence Antonella has been collecting is building up. Strandings in Greece, the Bahamas, California, Japan. So many lives lost. Why is it mostly the deep-diving whales who are dying all over the world? The effect of ocean noise is still little understood. Could their deaths simply be caused by the rising ship noise? What do they hear from our civilization? How do they feel about us? When the biologists see the whales, they're careful. They observe the whales' reaction to their own boat noise. When they approach slowly, the whales don't seem to mind. Documenting the whales is important. By recording their fins, which are as individual as our fingerprints, Antonella and her colleagues have begun mapping the whale populations of the area. Already they have had surprising results. Whales were thought to stay within the islands, but some males have been re-identified 2,000 kilometers further north, while the females with their offspring remain here, forming the nucleus of their families. Suddenly, boat noise. A whale watcher. A mixed blessing. Whale watching creates interest and awareness, which is good. But the bubbles in their wake burst into a hissing chaos, generating high frequencies. Masking the communication of the whales, creating a noise barrier through which the whales have difficulties communicating. That's why whales much prefer large sailboats to small speedboats.
The whales are still close, aren't they?
Most likely the whales can communicate at short distance without problems. But when acoustically separated by hissing engines, they can no longer synchronize with groups further off.
This is good. They are staying. But they are separated by the boats over here and there.
The biologists don't interfere, but try to understand the impact of the whale watchers.
But how many boats are here in total? And to whom do they belong? Do they have a permit?
How does all this activity influence the deep dive of the whales? Two islands away, Antonella's colleagues are busy deciphering the mystery of the deep dive. From land and sea, Mark, Natasha, and their colleagues use antennae to look for the D tag they attached to the whale a day before. The signal always comes from the same direction, which means the D tag has probably detached from the whale. But did the tag function as reliably as expected, even under such enormous pressure? The team can't wait to find out.
Tag recovered. The tag is on board.
If everything went well, all of the whale's movements in the deep sea will become visible for the first time.
We have recovered the tag and we are already going to the harbor.
The scientists have been waiting for this moment. How deep do whales dive? Do they hunt alone or in groups? Do they glide like birds into the deep sea? How do they navigate through the deep ocean currents and still manage to orient themselves? The answers to many questions should be hidden in the D-tag data. Natasha and Mark are eager to know whether the D-tag recorded all the details as they had hoped.
All right, let's see what we've got.
Mark starts the data transfer via infrared. A moment of suspense. How, from these endless numbers, to reconstruct the behavior of the whales in the deep sea? Not an easy task.
All right, that looks like the data's come off great. There's the dive profile. This is beautiful data. It's so dense, but to visualize this in 3D, we should send it to Berlin and get them to work it up.
Yes, let's do it.
Let's do that, yeah.
In seconds, the computer code arrives on the servers of Seabase, a group of computer geeks who usually work on projects like three-dimensional spaceships. The 3D experts immediately decode. The second column represents the depth. The last column indicates the fluking. Now the task is to create a virtual whale and a program to make the whale dive precisely like the real whale, but now for the first time ever within an authentic virtual world.
Send it over, please.
It's teamwork between various fields. Program code has to be written.
First, I'm going to transform the positioning data into a line. We'll see how it looks. Then we'll add the rotation from there.
This model is still far from a real whale. The people from Seabase work in different teams, each with their own task. The difficulty is in merging the different data sets. The skeleton contains clues on how to simulate natural movements. They've studied how real whales move. Now their job is to teach the artificial whale to swim. Nobody has ever seen what a beaked whale really does in the deep. Its dive and behavior is reconstructed elegantly and authentically, down to 1,200 meters. Now the biosonar of the whale is added. To visualize their use of sound, their clicks are illuminated within the reconstruction. These are the submerged mountains in which the whale hunts. The dive comes alive. The team of Seabase did not create a work of fantasy, but the first scientific reconstruction of a deep dive. Now the data is transferred back to El Hierro. Mark and Natasha are waiting.
Well, look, the data's here from Berlin. We should go check it out, eh?
Yeah, let's go.
All right.
Antonella has also been invited. With traditional filming, it's been impossible to follow whales deeper than 50 meters due to the high pressure. Now, for the first time, the world will see how whales hunt to more than 1,000 meters depth. Will the tag reveal more about the cause of strandings? Which secrets has the digital spy brought back from the deep sea?
How's that look?
Fantastic.
Where no camera can follow, the digital recorded movement data reveals every behavior of the whale in finest detail. For a better three-dimensional orientation, a movement line is added.
It's fluking like crazy trying to get down that first 70 or so meters.
Then he stops fluking with his tail. Did the computer guys from Berlin make an error? Rewind. Again, he stops fluking. Glides on astonishingly at the same speed.
The lungs collapse and presume the animal stops being buoyant.
Now, like a bird through the sky, he floats downwards. The sudden glide shows that the whale has gained the same density as the ocean.
That's because we've seen in the tag that the animal's gone upside down.
Without a sound, he approaches the unsuspecting layers of prey way down below.
This is where he starts clicking, right here.
At a depth of 664 meters, he's found something, starts to curve. Even the faintest reflection of a prey would give away its position. Now only meters away, the echoes track a squid. The click rate quickens to a buzz. The calamar is lucky this time. Nobody ever saw how a whale hunts at such depths. In reality, it's pitch black down here. No light penetrates to this depth. In the reconstruction, his sound is made visible as light. The whale depends solely on his clicks and echoes for orientation. Every second, the whale takes an acoustic image with his biosonar. Echoes bouncing from the bottom are audible. He's reached 875 meters. Very few submarines can dive this deep. Now he is close to the mountain ridge. 20 minutes of diving without a single breath. How do the whales know where to hunt in these harsh underwater scapes? Is this knowledge passed on from generation to generation, or do they simply follow their instinct? The type of echo data reveals a swarm of deep-sea squid. At 964 meters, he circumnavigates them, then targets anew. Once he discovers something, his click rate speeds up to over 100 per second.
But we get just a lot of different types of echoes, strong echoes, weak echoes.
A second beaked whale appeared, 200 meters away. The difference in echoes reveals the hunts of other whales, even their relative positions.
He stopped fluking at that point and then rolls right over. We've seen other whales do that. That's because we've seen in the tag that the animal's gone upside down. The head turning we can tell because we can see that the angle that the sounds are coming from. Here he goes, look there, he stopped fluking, rolls over, right about now, takes the prey item, very steep ascent, and now starts fluking again, starts clicking, right on, looking for the next thing. That's beautiful.
Every fast chain of clicks indicates a further hunt. It's not the giant squid they're after. They take about 30 small meals per dive. Now back to 566 meters. After spreading out during the hunt, the whales meet up, recognizing their group by the position of their sound. One is 150 meters behind him. A second, 30 to 50 meters to his right. Could be a calf. They end their hunt at 641 meters depth, gathering for the ascent, after having chased separately through the pitch-dark deep sea, covering many square miles. Their oxygen reserves must soon be depleted. Time for a last prey. At depth, all orientation relies on sound. But now, 40 minutes without air, it's back to the surface. Fluking steadily, he rises at a constant rate. Then suddenly he begins to glide. His lungs expand. For the last 500 meters, he's not uttered a single sound. His regained buoyancy returns him to daylight. Nobody has ever witnessed whales during their dive at extreme depth, surfacing 50 minutes later to finally breathe again.
At the surface, we don't hear that. And look how little time they spend at the surface. They just come up after 15 minutes down. They come up, take just a few breaths, and then right back down again to 200 meters, then 100 meters, and then shallower. But all of this on is silent.
The whales are at the surface for 2 minutes, and they produce a very special type of click, and it can help for the mitigation at the time of the use of the sonar. Before any sonar exercise, they should use hydrophones to listen for the beaked whales, and when you hear them, they should stop using the sonar.
The tag has shown that the whales normally surface slowly, resurface gradually by nature. There was no anti-submarine war going on during the recordings, but the assumption is convincing that whales move up too quickly to the surface when startled by sonar. All organisms expand when ascending. Would their bloodstream, saturated with nitrogen gas, start to form bubbles if depressurized too quickly? Why should a body built for diving get the diving disease? Is it a flaw of nature? Can one prove that whales panic at the incredibly loud sonar? It's necessary to learn more about whales and their reaction to the sounds in the seas. So far, the riddle has not been solved.